Okay, we're continuing on with lesson 1.4. This is video number 2, and we're working with example 1. Here we want to show that we have this set S. And in this set S, we have 1 plus 2 plus, it goes on and on, to plus n equals to n times n plus 1 all over 2, using principles of induction, of mathematical induction. Okay, so first thing we want to do is establish that 1 is an element in set S. Okay, so we're saying that this is set S here. So we want to let n equal 1. So in this case, we have here 1 plus 2 plus ... plus, so we're saying 1, right? So we're just using 1 equals to, replacing n with 1, and here we replace n with 1 again, plus 1 all over 2. So 1 plus 1 is 2, so this is 2 times 1 all over 2. To simplify, and we get 1 equals 1. So that holds. Okay, so part 1 is satisfied. Okay, part 2, now we actually add a part in here because we're saying let n equal to some number k. So we're substituting n with k. So now we're saying 1 plus 2 plus ... plus k equals to k times k plus 1 all over 2. Okay, so that's all we do there. All we did was just substitute n with k. Part 3, now we want to prove that n equals to k plus 1. So here we have 1 plus 2 plus ... plus k plus, now because it's an inductive set, right, we also have a k plus 1. So that means that where we had k, now we have a k plus 1. And then we have k, but now we're saying we have a k plus 1. So this would be k plus 1 plus 1. Okay, so wherever we had k, we have a k plus 1, which means we got this k also now has a k plus 1, and this k has a k plus 1, and then you have that other plus 1 all over 2. So that's going to equal to k plus 1, and then k plus 1 will be k plus 2 over 2. Okay, so because this 1 plus 2 plus k is equal to k times k plus 1, we can replace this 1 plus 2 plus k with k times k plus 1. So we're saying here that this 1 plus 2 plus k is k times k plus 1 because that's here in step 2. So now we're saying this will be k times k plus 1 over 2, but then we have this other k plus 1 here, plus k plus 1. And so we're saying these two are equivalent. So when we simplify this, we should get the same thing on the right side. So again, we took this, since in step 2 we had 1 plus 2 plus dot 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 plus k equals a k times k plus 1, we took this 1 plus 2 plus k and substituted that in with k times k plus 1, and we just brought this other k plus 1 down. So now we get a common denominator, so we've got to multiply by 2 over 2. So that's going to be k times k plus 1 over 2 plus, and this is in parentheses, so this will be 2k plus 2 over 2. And we're saying that equals to the right side. So we'll just put right hand side, RHS for right hand side. That's this. Okay, so now we combine it. So we go ahead and we distribute this k here and simplify and combine them. So this would be k times a, k is k squared, plus k times 1 is k. And now we're going to put all this under 2. So we're going to put plus 2k plus 2, since there's a common denominator, we can combine them. Equals to our right hand side. So now we have k squared. We've got 1k plus 2k, that's 3k, plus 2 all over 2. Okay, so we can factor that. All over 2. And we have k, and our signs are going to be plus, and that'll be factors of 2 are 1 and 2. So, yes, this left side and the right side are equal. They're the same. So we have proven through mathematical induction that what we set up here, set S, is 1 plus 2 plus n is equal to n times n plus 1, is through mathematical induction. And that's our example. Okay, if you had trouble with that, you may want to go back and watch it again. Thank you, and let me know if you have any questions.